the sine cosine can actually look at the unit circle, and then all of this is under the lecture note, so you don't necessarily have to worry too much about that. I strongly recommend you to upload it. So let's say the cosine of 2 pi over 3, for instance, so we can figure it out by looking at the x values, the x index. So the cosine of 2 pi over 3 will be negative 1 over 2. So I just want to have a little brief of from what we have learned yesterday. So some of you who have trouble with classwork, for instance, I do not know how to figure it out. What is the size of 3 pi over 4? So it's with the y index, and then you can figure it out. That is radical 2 over 2. However, on a calculator, that we should notice this. That we should notice that the and let's just check out a little quick. For the calculator, that we should notice that this is the thing that we can press in. So let's say you have to change to the radians, right? For instance, so I want you to look at what is the size of 2 pi over 3. So I can simply press in size of 2 times pi over 3, and then the result would not be radical 3 over 2, but it's going to give you 0.866. So which means that this will be equivalent to radical 3 over 2. For those of you who have trouble with this, so we can also write them down on a calculator when you do this. And if you're not very familiar with the radians, we can also change that to the degree by multiplying this by 180 over pi. And then after we change that to degree, we can also use the calculator to get the answers for this. So let me just repeat that again. So review of the trigonometry that we have, and then so the 0.866 is actually on the calculator. Okay, so that value will be giving you radical 3 over 2. So this is somewhat very important that we have to keep in mind, because on the final exams, so you might have to use the calculators, or you might have to use unit circle, whatever you want to, but you gotta be careful. Okay, the unit circle, the x represent the cosine, the t will be called the angle, right? So making sure that we understand the t is an angle. Okay, so and then we also have the y represent the size of t, and then the tangent will be y over x, and so on and so forth. And then we also have another value, which is radical 2 over 2. So when you press that radical 2 over 2, that's actually going to give me 0.707, which is on a calculator approximately. So that value would be equivalent to radical 2 over 2. Make sure that we understand that this value is not very complicated for you guys to read. But again, that if you just think of it like, what is 0.707 on my calculator? So we should have put that as radical 2 over 2. Okay, so this is going to be most likely is occur on a certain region. So I would tell you it will be the same for cosine sine. And then most of the angle that you can see will be 45, 135, 225, and 315 degrees, respectively. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, and so on and so forth. So we definitely going to use this kind of method to determine the sine, cosine, and so on and so forth. Are we good with this, people? So we also have the tangents of t will be equivalent to sine over cosine. And then this will be essentially important to deal with for the next chapter. But up to now, I think that everything is good. So the tangent would be the sine over cosine, so which is y over x on the unit circle. Okay, but we definitely going to stick with sine over cosine in the future, because we definitely have to go to the next of the most complicated chapter tomorrow, And I really want to make sure that people understand the concept here. And then the next thing that we need to know would be the SOHCAHTOA, right? The SOHCAHTOA is essentially important. So we're going to use it today as well. And that's pretty much it. There are actually more application, but it's not going to be on the final exam. I skip it. There are actually a few more chapters. So let's say I want to determine if this is a triangle. I want to see what it is. Okay, so generally the trigonometry basically tells us what? It tells us the relationship between the angle and the side length of a certain object. Okay, so SOHCAHTOA. Okay, so let me just put that down here. Trigonometry is relationship, determine the relationship between the side length and the angle of a certain object, specifically on a triangle. I mean, on the right triangle, determine, in triangle generally. So determine the relationship between angles and side lengths. That's pretty much it. Okay, so it might be the unit circle. It might be the things that we have it, but it generally tell you that relationship. We can have the angle, and then one side length can figure out the rest of them. If actually essentially important. So this is why trigonometry becomes so useful in architecture, engineering, especially the mechanical engineering for those of you who are looking for, and then the civil engineering for those of you who are looking for building the bridges or construction and stuff like that. So the trigonometry is a very, very crucial part of a certain object. So, but we're definitely not going to spend too much time, figuring out what it is, like, triangle things, but we definitely have to focus on something that we have on the final exams. So I believe that's fair. Instead of just talking about the concept, although some of the trick questions actually have a lot of application for it, but it requires some understanding, and then we don't really have time for it. So the SOHCAHTOA is essentially important when you have a right triangle. Remember, it has to be a right triangle, and that triangle going to tell you we have to determine the angle first. If you pick this one, will be the angle. So if you call this is T, and then this one going to be the opposite, right? So this one going to be the opposite. Okay, so we got to be really careful from what we draw, and so on and so forth. If we call this angle as T, in general, so we're going to have this one will be the opposite, and this one going to be adjacent, and this one going to be hypotenuse. So the hypotenuse will be unchanged no matter what it is. But the SOHCAHTOA is very, very crucial on the final exam. We really want to make sure that people understand and utilize this relationship. And the next thing that we're going to look at will be the inverse of the trigonometry of a sine cosine, right? So specifically sine, cosine, tangent, and that's pretty much it. We're not going to go like deep into certain inverse functions like a secant, cosecant. We do have it, but we're not going to spend too much time working on it. So the inverse of a sine and cosine, we need to understand that. So let's say I want to take the size of 30 degrees, right? And if I press on the calculator, so we can basically utilize the calculator to do it, or we can use the unit circle that we have the lecture from, which is the last lecture that we have. The size of 30 degree will be on the y values and will be on the y index, so the result will be 1/2, correct? The cosine of 30 degree or pi over 6 is going to give you the result equal to radical 3/2. However, I do not want people just memorize on the calculator saying, well, it's actually too much, right? And then you can pull up the unit circle on the final exam, which is great, but you need to determine that 30 degrees pi over 6, 45 degrees pi over 4, 60 degree pi over 3. So we should know the difference between the radians and the angles. So that's essentially important. So the next thing that we need to understand is that we're going to have to know how to press in the calculator. So I'm going to change back to the degree. If I use the radians function, you're not going to get 1/2. So I have to change back to degree. So the calculator will be understanding that, well, we're taking a size of 30 and essentially going to give me the answer with 0.5, right? 0.5. So I just want to repeat that. And then, so the reason why we need to understand is this one going to be the values, right? This one going to be the index on the unit circle or the certain values, right? Values, or in fact, it will be the y index, okay, on the unit circle. Okay, so we need to understand this one, the value, and then the other one will be the angle, correct? The other one will be the angle. Okay, so in other words, we're gonna have, this is gonna be the angle. So we can also have a function, let's say, y equal to size of x. So we're definitely gonna learn it for the next hour, but we need to understand that the y will be the values, correct? The y will be the value. And then the x basically will be a corresponding the angle. So basically what we need to do is that we have to identify which one will be the input and which one going to be the output. So the input will be the angle. So for every single value of x is going to generate a certain output. So the output in this case will be the value from the psi function, correct? So so similarly, that in order to look at the other side, so we need to understand that we have two different things. The one that we want to get to a certain angle, the other one is get a certain value or the side length of a certain angle, a certain side length of an angle in the unit circle, correct? So this is the thing that distinguish between mathematically. So we have like y equal to x squared plus 5, just plug in x, the input, you get the y, so they both values. But in trigonometry, one will be called the angle and the other one will be called the certain value. So I hope that this is not very confusing, but we need to understand which one will be the angle and which one will be the value. So when you have to take the sine or cosine or tangent or cosecant or secant, whatever it is, of a certain angle to get a certain value of it. Okay, so this is the thing that we should characterize, or in other words, to distinguish the differences. So in other words, if you have the size of 45 degrees, so you press in size of 45 degrees, so this is the degree, right? And then you're gonna get 0.707. For those of you who do not want to use the degree, we can change the mode back to the radians, which going to give you which we're going to give you the pi over 4. So let's say pi over 6, pi over 4, which represent the 30 degree and 45 degree respectively. You're definitely going to get the same result. Okay. Are we good with this? So so we need to know that there will be one angle. We need to take the sine, a trigonometry, a certain trig of that angle. You're going to get a value. Are we good? Am I going too fast for this? Okay, so you got this part, right? So now we're going to go to the inverse. The inverse of the trig, okay? The inverse of a trig. So what does that mean? So denoted by the size of -1. Okay, so this is what we have here. And then the cosine of -1. Okay, so and then the tangent -1. Okay, and then this is the secant -1. So I feel like most of this would represent the -1 on top. So remember, the inverse function usually that denoted by the f of -1 on top of it. So this is not 1 over something, right? So this is the inverse of a certain function. Okay, so now how can we play out with the inverse? So the inverse of the function will be, so let's say we take the size of 30 degree equal to 0.5. Then I'm taking the inverse of size of 0.5, but this one have to be with respect to the inverse. And then we want to figure it out. What is the value that corresponds to the inverse of psi of 0.5? So we definitely, so the inverse is playing around with the x and y. So y become the x and x become the y, correct? So you want to figure out what is the value of the angle, so such that I'm gonna get the result of I'm gonna get the value equal to 0.5. So this is what it means. Are we good? Are we good with this? So we want to find the values of the angle. We want to find the angle such that we want to find an angle such that the results such that size of that angle. Okay, so angle we call t equal to 0.5. Are we good with this? Is that good? Yeah. So in order to find angle, so we know the result right away, but how can we actually got to that angle? So we can also use the tricks, right? So we look for any value that gonna essentially gonna give you 1/2, right? 1/2 for y index, because this is around the psi function. The psi functions will be on the second index of the unit circle, right? So there's so many of them. There are infinitely many angles for this. Okay. Yeah. Exact form or decimal form, I would say, um, yeah. Yeah, we can write it down in terms of 0.5 or 1/2. For me, basically the same. However, I just want to remind you, when it comes to the final exam, I really want to make sure that people write up the point. Let's say I found the answer with 0.866. So I really appreciate that people write them down in terms of radical 3/2, because I need to return a final exam after I finish grading it. So they might have a look at it. So let's say 0.866, the answers that you should put there will be radical 3/2. And then 0.707, the answers that you should put there will be radical 2/2. So I strongly recommend people using the unit circle chart instead of the calculators, because it's more convenient, okay? So now you're going to find an angle that you're going to give you 0.5. There are actually infinitely many of them, correct? Infinitely many of them. It's the unit circle is just repeating for every 2 pi. So if you add another 2 pi and so on and so forth, they basically yield the same result. It just keep going around and around. So in other words, for every single atom that you can see right here, so there are actually 2 value that's going to give you, you know, I would say that's going to give you 1/2, correct? So they're actually 5 pi over 6 and pi over 6. Or in other words, it would be 150 degrees and 30 degrees. So in other words, so if we want to figure out the size of minus 1.5, so we need to be careful when you set it on the calculator. So we're gonna press second, you're gonna see that the syntax here will be size of -1, but it's going to only give you a single quadrant value, so that would be 30 degrees. So we can say that, so the size of -1 will be 0.5 will be 30 degrees. So we just have it on the pictures, okay? So the 30, a lot of people might think, like, can I write them down in terms of pi over 6? And the answer is absolutely yes. I actually prefer we write them down the angle in terms of the side length of a unit circle. I mean, it's the arc length of a unit circle. So we can also write pi over 6, which is great, but you can also keep the answers as degree, which is perfectly cool. However, if the question does not really told you whatever it is. So we're gonna jump to the unit circle. You can figure it out there another value that's gonna give you 1/2 as well. So that'll be 150 degree. Okay, so it's actually have multiple values when it comes to the inverse function, but I would definitely gonna stick with 30. Okay, we're definitely gonna stick with 30. So if the question specifies, I want you to find the size of -1.5 in the first quadrant, so the answer will be 30 degree, right? So this is gonna be the answers of on the first quadrant, right? This is on the first quadrant, which is right here on a unit circle. The first quadrant is 1/2, is 30 degree. So if the question specify that, well, the angle had to be bounded um, between the 90 degree and 180 degrees. So basically, this is on the second quadrant. So the answers for psi should be 150 degrees. So we gotta be really careful for that. But generally, when you use a calculator, you get what you get, right? So this is quadrant 1, and then this is the quadrant number 2. Okay, are we good? Very good with this, people. Yeah. Okay, so how would you get exact angle that doesn't exist? Yeah, so this is the thing.
Wait, Professor,
Yeah,
I have a question. It was a part of your like the homework from yesterday. So
okay.
I got a question like on, let me see. Like it was a question it was a question following the exact value from sin over like sin and 105 degrees. I was having a difficult time finding that.
Yeah.
I found it in a calculator, but I
Uh-huh.
couldn't find the exact value.
It's not easy. At 105, you need
Yeah,
to
because I couldn't find it in
yeah.
the unit circle and it was troubling me. So I
Yeah,
just found a
just put that
decimal.
down 0.965, 0.966. They do have the exact value for it, but this is really complicated. So
Yeah, I know
yeah.
I couldn't find that's the only problem I was struggling with.
Okay, that's okay. It's this 105 is actually 60 and 45, so they have to do the additions of the sine angle, so to figure out to find out the exact angle. I shouldn't really give you that question, but so we can simply just give me size of 105, and then I give you full credit for that, which is
Yeah, I did that
0.96.
and like
Yeah,
I was like,
yeah, that's
all
fine.
right.
That's fine. You don't have to worry too much about that. But the other angle should be on the table, correct?
Yeah, I found everything else except that one
Okay,
question.
okay. So let's say I want to look at the size of a pi over 3. So a pi over 3 should be uh no, there's no a pi over 3 actually. Um
To do like um
a pi over
so
3 is like 2 pi over 3 is basically the same as 2 pi over 3. So the issue would be -1/2. So we can also do on a calculator size of a pi over 3. So let me just change that to degrees or to radian. So let's say I want to look for size of a pi over 3. So a times pi over 3. So you're going to get this one, okay, which is radical 3 over 2. Same thing at 2 pi over 3. I would definitely going to emphasize that. But generally, everything is good. And I know there actually is some of the question that is more advanced, like how you're going to find the angle of a certain thing that not on the unit circle. So, all right. So we're definitely gonna go over it. So now we are having some of this. So let's say I want to find another side. So I want to find the inverse. So remember the inverse should be given, and then you should be able to figure it out on a unit circle, right? The following uh, or find the following inverse um, trigonometry, right? Okay. So let's say we're gonna have the size of the cosine of -1 of negative radical 2/2 over 2 right there. Okay. And then B, I need to find the inverse of the secant of -1. Okay. So this one is radical 2. Okay. I need to find the tangent of -1. So remember, the -1 on top, we need to find the inverse of that. So we need to be careful with this. So it's not like 1/10, something like this. So that would be radical 3 minus radical 3. Okay, so the whole thing is that we need to figure that out and how you're going to find the inverse. So I'm checking my phone if that's appropriate. Okay, so I am checking the phone. So I just want to make sure that I'm going to show you tomorrow if we can find the inverse of that. So essentially, it doesn't have that function. Okay, so there's no way that you can find the inverse on the calculator, um, which is sad. And then, so what we need to do, we need to use the phone calculator doesn't work for all of these values, so we've got to be careful. So let's say what you look for the cosine of minus radical 2/2.
45.
Is 40. It's actually it's
Negative
well,
45.
negative 45 is the negative 45 is actually not the things, right? So let me just change back to the to the degree first, because set it up to the radian. So we can also look it up on a unit circle. You bring this on a final exam, so it will be so much convenient. I know it's kind of cheating, but this is the way that can help us alleviate out of the memory part. So negative radical 2/2, so 45 degrees. So this is the cosine, right? So we want to find an angle such that, oh, and then such that the cosine of t equal to radical 2/2, negative radical 2/2. The cosine of t equal to the t. I'm going to change a little color for this, so we want to make sure that it's actually the angle equal to negative radical 2/2. Okay, so let me just do it very slowly for that example before we can start the other questions. So essentially, it's gonna give us a certain values, right? So this is basically the cosine will be the x index on the unit circle, correct? So we need to memorize this. The cosine going to be the x index, right? X index. The sine going to be the y index. So it's going to be the first point, right? The x and y, the x going to be the cosine, the y going to be the sine. So when you look at it, do you want to make sure that it's located on the x index? It's basically the same. So we can't use the first one, which is 45 degrees I mean, if you ask me about the negative 45 degree, we have to do backwards. Okay, the negative angle, we have to do the clockwise direction.
Yeah, then you got to do 180 minus 45, which gives you 135.
135 degree, yeah. So I didn't know that how you learn this stuff, like how you're gonna take 180 minus this, but which is good. You are basically one step ahead of us. I mean, pretty cool. Um, so what I'm saying is that we can't do this as Chris just mentioned earlier. We can take 180 minus this, okay? So essentially, I'm not sure how we're gonna explain because we haven't got that. We haven't really got to it. So we're gonna change the angle until we actually go to the basically the last chapter, the last part of the chapter. But we essentially going to look at the unit circle that satisfy the x index equal to negative radical 2/2. So it will be 135 degrees. And there's another index that satisfies radical negative radical 2/2, which is 5 pi over 4 225 degrees. So remember, the cosine would never be negative on the first quadrant and then the last quadrant, right? So the angle that you found should be bounded between the second quadrant or the third quadrant. It cannot be in the first two quadrants because the first two quadrants give you the positive x, right? The positive x, right? It's on this side. It's on this side. So you will not get the negative x value. But the answers give you the side length, the value of negative radical 2/2. So essentially, the angle T have to be either on the second quadrant or on the third quadrant. So both quadrants that satisfy radical negative 2/2 has an angle equal to 135 degree and 225 degree. Are we good? Are we good with this, people? Hello? Is that good? Okay.
Yes.
This is quadrant 2. Okay, and then this is quadrant number 3. Just want to make sure the cosine cannot be negative. Okay. On the first and the last quadrant. So the first quadrant is positive, the last quadrant is negative. So now we're gonna do this as well. So the secant is actually not gonna be in a calculator, so that's not gonna be on this part either. So how can I get the secant of this? Okay, how can we get the secant of this? So what kind of trick that we have to look at so that we can find the secant? We're gonna find angle, right? Again, I'm gonna find angle such that the secant of -1 radical 2 equal to negative 1t equal to radical 2. Second. Equal to radical 2. Okay. So it's not on a unit circle, so we can figure it out, right? So anyone can tell me like the way that we can think of it? Maybe what is the value for t equal to?
As R.
Yeah. What is the value for t such that like a secant equal to the secant of that angle equal to radical 2, right? The same, correct? We can find a cosine of a -1 and then invert. Yeah. So those two probably basically the same thing. I told you those two probably basically the same because the secant is the secant of t equal to 1 over, right? 1 over 1 over the cosine of t, correct? Everybody know that the secant is it's not an inverse, okay? So it's basically the 1 over, right? 1 over is a reciprocal. I use the word inverse, but that is wrong because when it comes to this chapter, then we have trouble with this, okay? So if you have trouble doing this, okay, so just do me a favor, right? You're gonna draw a triangle. Okay, draw a triangle here. And then you're gonna look at that. Okay, what are the secants? What do the secant means? People, the secant is hypotenuse over adjacent, correct? Right? Because the cosine is adjacent over hypotenuse. The secant would be hypotenuse over adjacent. Okay. So adjacent is gonna be 1, right? So this is what we call an angle. So we want to figure it out what it is first. The angle t, right? So the adjacent is gonna be 1. And then the hypotenuse in this case equal to radical 2. Right? Essentially, A and B are basically the same thing. So we can also find the opposite side length in this case. So the opposite will be what, people? The opposite square plus the A square plus B square plus C square equal to 1, correct? So if you don't know what it is, we can actually use this method to figure it out. So we have A square plus B square plus C square equal to 1. I'm sorry, plus B equal to C square. And then you can figure it out. So this is radical 2 square is 2. So you can figure out the opposite square equal to 1. You take the square root. So I just simplified it. So it's 1. Right? So the opposite that we got is equal to 1. So that we can figure it out the angle appropriately. Okay. Are we good? Are we good with this? So now we can think of it. So if they have the same thing, so what is the inverse of that angle? That's going to give you radical 2. Actually, we don't need to use this method, but so I know it's these two problems going to be the same thing. Let me just find out the way that we can explain it much better. So 1 over radical 2. So the secant is 1 radical 2 over 1. So now we can think of it. What is the angle that's going to give you the same? So the t should be 45 degrees, correct? Right? Right? Correct? 45 degrees. They have the same length. So we actually don't use, I don't think this method is better. It's not a better suit for another problem. I will show you another problem. We're going to use this method. But so this method will be used to determine the secant of this inverse of secant, which is equal to radical 2. And that going to give you the side length, right? Which is the hypotenuse over adjacent, which is radical 2 over 1. So the adjacent will be 1, hypotenuse radical 2, and then you can figure it out using A squared plus B squared equal to C squared. Okay. And then we can figure it out that out of this, and then we can figure out the opposites is 1. So in fact, the inverse of the secant basically 1 over cosine. So it's basically the same thing if we take the cosines. So if we want to find the t such that the cosines of t equal to 1 over radical 2, the same thing, right? But I'm not trying to overcomplicate the question. But what I'm saying that we want to find an angle that satisfies this question, right? So when you look at the inverse of the secant, so let's say the question gives you radical, which is give you radical 2. So we can think of that. We can think of that the secant is the reciprocal of the cosine. So it's going to be the same. Then you're going to take the inverse of the cosines of 1 over radical 2, or radical 2 over 2. Okay. So so in this case, the angle t that satisfies this question, the angle t that satisfies these questions will be on the 45 degrees and 45 degree and 315 degrees. Okay, 45 and 315. So does it make sense a little bit? I know it's going to be really hard to make sense of what we're doing here. Correct? Yeah, 45. So we can try them out. So for that part, how can we find a secant for this so we can try it? So first, you're going to look for the cosines of 45, right? And then we're going to take the inverse. We're going to take the reciprocal for that. So 1 over reciprocal, which is 1.414. So which is exactly the same thing at the back that we have, which is radical 2. Okay. So it might be hard to find the inverse. It might be hard to find the inverse of the secant and tangent because it's now going to be on a unit circle. So so I think that the appropriate way that we can think of it is we're going to use this trick. Okay, and then whenever you see that the secant, you always have to think of the cosine. So and then you're going to flip this, right? So now, if I want to change this question, I want to change the question B. Okay, so I'm not going to do C anyway. I'm going to do it later on. So I want to change the question B into the cosine of -1, right? But you know that the value of the cosine is the flip of the secant. So we're gonna go for like radical, the flip of this is which is 1 over radical 2 or radical 2 over 2. Okay, does it make sense, people? So is that good? So we can think of it. Are we good? So we need to find the inverse of the cosine, but instead of we putting the same value, you're gonna flip that. So I can just find out on a calculator, which is 1 over radical 2, which is radical 2 over 2. There's 2 of them, is 45 degree and 315 degree. Using this method, actually much more complicated. So we can figure it that way. So that will be either 45 or 315. Are we good? Are we good with this, people? Hello? Is that good?
Yeah.
So remember, we just flip the values of the secant. You got it. Flip the value. Okay, let's do more practice. So I think I stick with sine cosine. So just give you, I think it's the final exam questions only give you sine cosine. It cannot be that complicated to give you the secant. So we can use the unit circle to figure it out. So let's say size of -1 of the size of -1 of 1, right? So what is this? Okay. So now we can use a calculator for that, right? So size of -1 of 1, so that will be give you either the 90 degrees and so on and so forth, right? So we can think of that, which is the y value, the index will be 90 degrees, or I feel like that's pretty much it. That's the only index that gives you 90 degree and then give you the y index equal to 1. So that will be only one value for this. So the would be equal to 90 degrees. Are we good? Does it make sense? Can everybody find this angle on the unit circle is 90 degrees, correct? So it's gonna be on this part. Are we good? All right, so now we're gonna go to a very essentially really hard. So now let's say the size of -1 of the cosine of one radical derivative. And then you'll be asking me like, what? I haven't seen this problem before, right? So it's really hard to determine this angle, right? How can I figure that out, people? So what do you think? Uh, actually, we find a cosine of, yeah. Okay. So so what we have to do, we just need to figure it out the cosine of radical derivative 2, right? No, actually, it cannot be like this. It should be the other way around. I'm so sorry. It should be the other way around. It should be -1 on this side. I think I make a mistake. Okay. So I want to find the size of cosine of -1 of radical derivative. Over 2. Okay, so think of it. We need to figure out the cosine of radical 3/2 first on the calculator, correct? And then you can find the inverse of the sine. So now we can just take the cosine of radical derivative. Okay. Quick. Actually not working like this. So what's going wrong with this? Okay, so it's kind of weird. So let me do that one more times. The cosine of radical derivative. Okay, let's check it out. So 30°, are we good? Are we good with this, people? So we can figure it out first, and then we can replace by a sine cosine. So this is 30°. Are we good, people? And then we can take the side of this size of 30°, and then it's gonna give you the size of 30° equal to 0.5. Are we good? Is that good, people? So that will be 0.5. Is this hard? Is this too hard for us or no? We just simply have to figure it out. What is the angle for the cosine of the inverse of cosine of radical derivative 2? So the angle for that will be 30°, or will be 330 degrees. Okay, so there are actually two values that satisfy the cosine of the inverse of cosine of radical derivative 2. So that would be 30° or 330 degrees. So if the angle is 30 degrees, so we can find the size of 30 degree. And then the size of 30 degrees is basically the x index, the y index. So, and then the answers for this, we just switch it, correct? We just switch the x and y in this case. So we also have the size of 330 degrees, so the answer will be negative 0.5. So if you still not so clear about like how we're gonna get those two values, so we're going to look at the unit circle in this part. I'm gonna copy that part and essentially gonna post it here so we can look at this and a lot better. Okay, in fact, this is right here. So 30 degrees, so we're gonna get the y index. So the x index with cosine, we're gonna get, and so we're looking for the y index of this is 1/2, right? So this is the answers. Okay, and then another part of the answers will be on the bottom. So when the value for cosine is radical 3 over 2, so the value for size in this case is negative 1 over 2, right? It's because that corresponds to 30 degrees on the pictures and 330 degrees. So you're gonna get the answers right away. Okay, are we good? Is that good, people? So I don't think this is gonna be on the final exam, but I'm not sure because I saw them on the exam review. So I just need to cover it. Okay, so if this question is not going to be in the final, so we can just find the inverse by looking at a unit circle. Are we good with this? All right, so any other question? Any concern? Yes, of course, it's not a big deal. So we can leave the answers as 1/2 or 0.5 or negative 1/2, except for like a radical derivative. If you leave it at 0.866, it might be weird, right? So you want to leave the answers radical 3 over 2, or 0.707, you might want to leave the answers as radical 2 over 2, okay? So this one essentially pretty easy. I want to find an angle. I want to find the value of an angle that's going to give me the cosine of radical 3 over 2. So in other words, the angle should be the same for the x index of radical 3 over 2. And then all we need to do is just find the sine, which is the y index of the same angle, which is 0.5 negative 0.5. Okay, so I believe that's pretty much it. And we're going to move up to the next part, which is called, it's definitely going to be the final exam. Okay, trigonometry function. How does it feel so far? Is this hard? How the course so far? I know it's gonna have, we're gonna have 2 days left. That's it. 2-day lectures and tomorrow lectures, and then the final review, and then that's it. And we're gonna see each other on Tuesday. We're gonna have a final exam Tuesday. Okay. Trigonometry function is actually one of the very complicated, but it's manageable if we know what it is. Okay. What time for the exams? The exam time will be exactly the same class time, will be from 9 to 11. From 9 to 11. The final exam, let me just put that down really quick. Yeah. Because I decided to give people a day up for that part, and then I told us earlier that I give people 2 day up. The 1 day up gonna be on 16, another day up gonna be at 23rd. And then I don't think that people are going to be much better if you don't take a break on 23rd, and then we can have a final exam 24. So so this is what I'm saying. Okay. But I will be on the office hour on Zoom if you want to discuss a certain issue on Monday. But generally, on Tuesday you can have a page of notes on a final exam. I'm going to tell you exactly how many topics on the final review on Friday, so you don't have to worry about that. Okay, we're going to do the practice final exams as well as the things. Okay, so this one, the final exam is gonna be on Tuesday, 25th. I'm sorry, 24th, January 24th. Okay, and then the times will be from 9 to 11. I will give you 11:30. Doesn't matter. Okay, so that'd be 2 hours and 30 minutes. So I mean, you can stay as long as you want to, but I don't think that people are gonna stay for 5 hours. You have to, and then you might have a lot of trouble with this. Okay, so and then the Fridays, please come on Friday. This is a very important day. So how many questions? I would say that infinitely many questions. I'm just kidding. So I gonna say infinitely many hours for final exam. I would say we'll be around like 9 to 10 question. Each question is gonna be like some graphing and so on and so forth. 9 to 10 question. Okay. And then and after the final exam, we try to post the grade like immediately. Like let's say if you have the exam on Friday, I'm definitely gonna post the grade on Wednesday night, so that when the semester started, so we will have enough time to do the rest of the course for those of you who fail. But I don't think that any of you who fail my class generally. I'm not sure if if one of them. But if you take the exam, you get around like 70 or something like this, you should pass the course. Okay, so are we good? I mean, assuming that you do the classwork and then the quizzes. If you don't take the quiz, you lose 50% of your grade. If you don't do the classwork, you lose 10% of your grade, correct? I did mention that earlier. Quiz and classworks are 25% of your final grade. So please do it. Okay, so now we're gonna go to the next lecture. So it's pretty much on chapter 6, periodic function. We call it trigonometry function. Okay, so we need to know that the periodic function, the function of P itself, in a certain domain of X. Okay, so I'm not gonna write them down because it's all you know. Trigonometry functions, trigonometric functions are periodic function. It has certain period of amplitude. So let's say we have the sine and then the cosine. So I think I need to copy that part so we can see what it is. Okay, so let me just post that. And then because we need to understand what it means by the period in this case, so where it's basically going to be repeatedly on the curve model. So the amplitude in this problem, is the height, okay? The height starting from the origins, right? The amplitude is the height of a function, okay? So starting from the origins, but we need to just look at a coefficient of a function, okay? The period of functions, on the other hand, is basically before it repeat itself, right? So like the cycle that a function repeat itself, right? So how can we determine that? You're gonna look at the coefficient of X. Okay. Okay, so so now let's go to the functions y equal to sine of X, right? So we want to look at a function, the trigonometry function. So I would say there are 4 of them, but we only cover 2 of them. So we only cover sine, cosine. So this is what we have for sine of X, and then this is what we have for the cosine of X. Okay. Are we good? Are we good with this, people? So in order to figure it out, and then we need to use the radian. So this is why I always ask people to use somehow to use the radian instead of the degree when it comes to uh, the sine cosine functions. In this case, so we have to think of it like 30° will be pi over 6, right? 45° is pi over 4 instead of degree. You need to use radian. Okay. All right. So in order to beef that up, so we're going to look at the value that we generated on the unit circle. So this is what the sine function looks like. We can also check it on a calculator, and then but we need to make sure that it's actually fit on a calculator. Let's say we're gonna use it on the mole, and then you have to be changed that to the radian. So now I want to look at what is the size of pi over 6. So we're gonna go size of pi over 6. Which is 0.5. So all of these values, so let's say the input gives you a 0, the size of 0 is 0, size of x equals pi over 6, the result for y equal to 1 over 2. When x equals to pi over 4, the result for sine will be radical 2 over 2. When x equal to pi over 3, the result for that is radical 3 over 2. Are we good? Are we good with this? So in other words, we're going to look at the sine, which is on the y-index. So it will be 0, you're going to get 0. If pi over 6, you're going to get 1/2. Pi over 4, you're going to get radical 2 over 2. Pi over 3, you're going to get the y-index is radical 3 over 2. Pi over 2, you're going to get the y-index, which is 1. And keep going, 2 pi over 3, you're going to get the index will be radical 3 over 2. 3 pi over 4, you're going to get the y-index will be radical 2 over 2. The y-index representing the sine. Pi over 6, the index is going to be 1/2. And pi going to be 0. Are we good? This is what we have. Are we good with this, people? Everybody can see this on a unit circle. Is that clear or not so clear? Okay, it's clear, right? Those are the side. Remember, the side with the y-index that you can get from the unit circle. Make sure that you have this chart, because you don't want to do it like every single time. So let's say I want to check the size of 5 pi over 6. So 5 pi over 6. So we don't want to do that because we know that the y-index, the side will be 1/2. So we're not going to do it every single time. So we can simply just looking at the index for that, right? So if you ask me how can we get the unit circle, so we can just figure it out. Just going to use the images. I feel like this image look better. I'm not sure, but some images doesn't look so clear. But we need to have both degree and radian. This one not good. This one only give you degree, but we need radians in order to sketch it. So we gotta be really careful with this. Okay, you're gonna pick the one that you copy, and then you can just post it, and then you can print it out. Okay, you print it out for you on a final exam. Are we good? Is that good, people? Okay, so the next step that we need to do, we need to sketch it, right, from 0 to pi. And then we have to go for 2 pi. So the period for this is always for both side functions. For x is always be 2 pi. So when we sketch it for a single pi, what it looks like, it's gonna go like this. Okay, it's gonna go like this, right, for a single pi. And then we can keep going from pi to 2 pi, so we can start up a chart, but I'm not gonna do it, but you have to imagine what the curve looks like. So from we're gonna from pi to 2 pi, so we're gonna look at, we get all the y-indexes for side function. So from 0, we're gonna go down to -1/2, and then it's gonna go down to negative radical 2/2. It's gonna go down to radical 3/2 and go down to -1, and it's gonna go back up to radical 3/2, radical 2/2, and radical and the -1/2, and then gonna go back to 0. Okay, so this is what the value of the side function between 0 to 2 pi. Are we good? Okay, so when we sketch the curve, generally the curve will go like this for the side function. Okay, so it's definitely gonna go. So for the first period, it's gonna start. It's going up from the origins because sine 0, 0. So this is like pi over 4. So pi over 6. So what is the value of pi over 6? But this is the pi over 6, correct? The value for that is 1/2. Everybody see that? So this is the 1/2 over 2. Everybody see that? So this is 1/2, right? Are we good? So this is 0.5. This is pi over 6. And then pi over 4 is around like 0.707. And then pi over 3. And then if x equal to pi over 2. So remember, the x-axis, the x going to be the angle, but the angle in terms of the radian. Okay, the y value is going to be the value, right? So this one, the value that we can find in the unit circle. So can we find a unit circle? So now we can basically figure it out. So size of pi over 2. So you can figure, we plug in at x equal to pi over 2, and then you plug into the function. So y equal to sine pi over 2, you're gonna get the answer what you want. And then you can see that the value gonna decreasing to when we increase the angle to 2 pi over 3, and then so that would be radical 3/2, and then 3 pi over 4, which is radical 2/2. You're gonna get the same points here, and then 5 pi over 6 is 1/2, and pi is going to get 0, correct? So y is going to be the points right there because the size of pi equal to 0. Are we good? Are we good with this, people? Do we understand how we're going to sketch on the sine cosine function? Are we good? Are we good with this or no? Do we understand how the curve moves? So the x-index gonna be the degree, correct? The y-index, I'm sorry, the x-index is gonna be the angle, but in terms of radians, the y-index is gonna be the value that can find on the unit circle or a calculator. Okay, are we good? Okay. Not really. Okay. Right. So remember, so the pi is what? And a lot of you might ask me, what is the pi? Right? And how can we divide it on a unit circle? Correct? Right? I'm saying on the x-axis, the pi was simply 3.14. Okay, so this one, the radians, this one gonna be 3.14, right? And this one gonna be 3.14. Okay. The index, the value for this. So this is why, and why we cannot use the degree, because we cannot just like divide it like into 30 degrees, 60 degrees, 90 degrees, 180 degrees, so on and so forth. It's so hard. So this is why we're gonna use the radians, so that the radians also represent the arc length. The length and the value are the same unit. So this is why we're gonna use the radians on the trig function. So meaning that for every single time that we want to sketch the function, so we're going to start up with the pi to 2 pi. So we determine what it is. So the period for this would be equal to 2 pi. Okay, 2 pi because it's basically the entire unit circle. Okay, so now I will talk less about a unit circle, but I will focus more on what we study now. Okay, the amplitude, the amplitude will be equal to 1 because the height for this is 1. What percentage of a lot? It will be 40% of that. I'm just kidding. I'm just kidding. It will be something that we just studied yesterday. It will be one question. There will be another question like this. Just hold on to it. You just need to understand because I'm gonna show you the trick how I'm gonna sketch the function properly. Okay, and then and then there'll be another 2 questions regarding to the trick identity, which is hard, and also the thing that we have on the trick function. Yeah, this is the thing that we have on the final exam. Yeah, so because it's changed to negative, so a lot of you might be wondering why this one's going down because on a unit circle, the y value start decreasing from 0 to -1/2 to -3/2 to negative radical 2/2 to negative radical 3/2 to -1, and then start increasing back up. So that'd be negative radical 3/2, negative radical 2/2, and -1/2 and 0. And it's come back to 0 at 2 pi because size of 2 pi which is 0. Okay, are we good? I know it's a very terrifying, but I don't think that we going to deal with that too often. But we just need to memorize the curve. The side is going like this. Are we good? Okay. Are we good with that? It's like in I don't know. What does it look like? No, it cannot start at 2. You have to start from 0 and then we shift it. And then we shift that. You shift to the right, and then I'm gonna show you how we shift it, okay? Yeah. We have to start from 0. Okay, start from 0. That's a good question. Can we start at 2? No, we have to start from 0. Can we start at pi? No, we have to start from 0 because there's no changing of the x index. We do learn it later on, but generally the side functions start from 0. We're gonna shift that curve using transformation. Okay, are we good? Are we good with this? We just need to understand how the curve looks like. You don't have to be exact. Nobody can be exactly sketch the side function because there's no way you can figure out those index appropriately. Let's say this is 1/2. This is radical 3/2. This is radical 2/2. This is radical 3/2. This is 1. No. Okay. So now we look at the cosine function one more time. The cosine function's gonna go like this. Okay, so this is what we have for the table. Are we good? So how can we find those values? So the cosine of 0 is 1, the cosine of pi over 6 is radical 3/2, the cosine of pi over 4 is radical 2/2, the cosine of pi over 3 is 1/2, the cosine of pi over 2 is 0, correct? The cosine of 2 pi over 3 is -1/2, and so on and so forth. Are we good with this? Or no? Are we good? Hello? So you can figure it out. So remember the cosine is different. The cosine started from 1 and then going down to radical 3/2, going down to radical 2/2, going down to 1/2, and going down to 0, and going to -1/2, going to negative radical 2/2. Look at the x index when it comes to the cosine. a negative radical derivative, -1, negative derivative, and then it start increasing back to 1 after 2 pi. Are we good? So what the curve looks like? The curve of the cosine functions is going to look like this. Okay. Are we good? So remember, the cosine start from what? Where? The cosine start from people. Star
1.
1 at the high is 1, right? Star at 1 at y equal to 1. Okay. Are we good? Yeah. And then it's gonna reach 0 at pi over 2, and then it's gonna reach -1 at pi. Okay, so reach -1. So cosine of pi equal to -1. So, and then it's gonna reach 0 as like a, so this is 1 period for this. The 1 period for that is 2 pi. So half of that is gonna go, so a quarter of that is gonna reach 0. And then another quarter of that is gonna, another quarter is gonna reach the lowest point, and then another quarter is gonna reach 0, and then another quarter of that is gonna reach back to 1. Okay, so the cosine function should go like this. Okay. Are we good? Does it make sense? You just have to sketch like this. I give you full credit for it. Okay. Are we good? The period still will be 2 pi. It's basically 2 pi, and then the amplitude is 1 as well. And then the amplitude is 1. Are we good? Are we good? Yeah, it's always stay the same, and then we change certain index for this. Okay. So the periodic functions with the horizontal shift. Okay, is a horizontal shift. After 1 period, you're going to repeat itself. Okay, so now when we look at the sine cosine function, how does it feel? Do they actually the same thing? But the graph for 1 period is not the same, correct? Do you think? What do you think? So the periodic function is like a horizontal shift of the function. So this is what you have for the sine cosine. What do you see when you see those pictures? What do you think? Do you think they're the same thing? So for the one single period, right? For a single period, it's gonna go like this, correct? Oh, it actually is from pi to 2 pi. So this is, yeah, stuff at 0 to 2 pi, but I don't enjoy it properly. Okay, everybody sees that? And then for 0 to 2, from 0 to 2 pi, it's gonna go like this for cosine. All right, are we good? Everybody see that? So this is for sine, this is cosine, but they are basically that they are technically the same thing, right? The only thing that make them different will be the shift. In fact, if we take away 90 degree from sine or cosine, you're gonna get back to another cosine function. So I take 90 degree from the sine, and then I'm gonna get back to the cosine function. It would take 90 degree from the cosine, I'm gonna get back to the sine. So the only thing that make them different gonna be the shift of that period. Are we good? But the cosine should go like this, and the sine should go like that. Okay, are we good? Does it make sense? Okay, so I know it's very confusing. So focus on what the final exam looks like. So okay. All right, so the period is gonna shift depending on the angle for this, depending on what it is. Okay, the A we call the amplitude is also a periodic shift. Okay, so let's say I want to sketch the function. Okay, I want to sketch the function. So this is what we have on the final exam, okay? Y equal to 2 psi of x, what do you think? Two sides of x. It start at 0, still start at 0. Now I'm gonna do like this, okay? So this is 0, and this is 2 pi, still 2 pi. I didn't really change that. So what is different? What is different between the functions? So this is 2 pi, right? This is 2 pi. So so this is 1 pi, this is 1/2 a period. So this is pi. So you know, we do know that the side function should go like this, correct? Right? Yeah, exactly. So the only thing that makes them changing would be the amplitude, okay? The amplitude. The amplitude for this, okay? Equal to 2, right? And then the period still be 2 pi. Still be 2 pi. Yeah, this is really screwy. And then after that, we're going to move up like 2. So we have like, this is 2. And then this is like, you don't necessarily have to be like, so pi is 3.14, y2 is higher, taller, so it doesn't matter, okay? So we're just like approximately what it is. Okay, so this is 2, this is -2. And then what the curve looks like, just still be like this, right? I really have such a hard time sketching. Are we good? Are we good with this? Yeah. So if I want, remember the final exam, I'm going to ask you to sketch 2 periods, so you're going to get the same thing. So this is, so from 0 to pi, this one from 0 to -pi, right? And so on and so forth. This is 2 period, okay? If the question asks you to sketch 2 period, you're going to do that. Okay, do the same thing, okay, on the left. Yes, so the number before the sign going to be the amplitude. Okay, the number before the sign will be the amplitude for this. So let's say we have the higher function, the coefficient of functions before the sine and cosine. Yeah, no, it depends. Depends on the x. So we'll give you another example for that. So sketch the functions. Another example will be y equal to 2 side of how many x do we think is better? Let's say 4x, okay? Yeah, so we're changing the period. So the period depends on the coefficient that go with the x, okay? Does that make sense? Okay, So now we look at the amplitude. So what is the amplitude for this? Let's change that to 3, so make it look nice. Let me just rewrite them. So instead of we having like 2, I'm gonna change that to 3, size of 4x. Are we good? Are we good with this, people? Everybody sees that? So what is the amplitude for the function? Is how many? How much? 3, correct? Very good. And what is the period for this? So remember, the periods for x will be 2 pi. Now we have 4 times of x. So for every single x, so let's say we have 30 degree, you have to multiply by 2, by 4. So you have to make the period hello. We have to divide it by 4, correct? Are we good? Because the coefficient is 4. Are we good with this, people? So the period will be, we're going to generalize it later on. So whenever you see the coefficients, that we go with the x, so we're going to divide it by that coefficient. Are we good with this, people? Is that good?
Should be pi over 2.
Pi over 2, that's correct. So that one should be pi over 2. Okay, so I'm going to sketch the graph, so it will be slightly different. So now, how can we sketch the curve with different periods? So we're going to start from 3, correct? Are we good? Is that good, people? We're going to start from 3 and -3. Any question for this? Are we good? So the whole period will be 2 pi. I'm sorry, it's not going to be 2 pi. It will be pi over 2. Everybody sees that? So this one will be pi over 2. I really don't like pi, actually. I wish. Everybody sees that? So the whole period is pi over 2. What is the half period for that? People, how can I put this down here to make the curve looks nice? What is the half period for this? So the half period going to be, so we take pi over 2, we divide it by 2, correct? We take pi over 2, we divide it by another 2, so that'd be pi over 4. Are we good? People, is that good? Hello?
Yeah.
So that's going to give you a curve like this. Are we good? So we can also sketch another period for this. So this is pi over 4, this is negative pi over 4, and this is negative pi over 2. Okay, you don't have to, but the final exam they're gonna ask you to sketch another period. Are we good? Hello? Do we understand how we're gonna get pi over 4? How do you know that where that is? Because the whole period is pi over 2, so we have to play a whole period first, and then you're gonna divide it into half, so that'll be pi over 4 and pi over 2. That's it. I'm not gonna care about the another pi over 8 and then 3 and then 3 pi over and then and then this part. So I'm not gonna divide it into another quarters. It takes too much time. Okay. Are we good with this, people?
Yes.
What is the range for this function? The range will be the amplitude, correct? Between -3 and 3, correct? The domain is basically everything. Will be OX, correct? This is X perfectly good. The range is cannot be more than 3 and -3 because it's the coefficient for that. Any question? Any concern? So we have to draw out the entire period. How can we find a period? The period for sine cosine is always be 2 pi. Whatever the coefficient that we have, we just divided by that coefficient. So the coefficient for x is 1, just take 2 pi over 1 is 2 pi. If the coefficient is 4x, take 4, so we take 2 pi over 4 is pi over 2. We haven't finished it. We're definitely gonna do 2 or 3 more with the cosine. I'll let you go. We still have time for that. Okay, this is the last topic for today. Tomorrow we're gonna go. The class will be in person, right? Tomorrow the class is not gonna be on Zoom, so please come to the class in person tomorrow. We're gonna have an additional quiz, and then it's optional quiz tomorrow, but the topic gonna be really important. So please come to the class tomorrow, and then we're gonna do the work. If you don't want to take the quiz, it's fine. But today we do have a quiz, correct? Yes, we do. Andy, we have every quiz, every classwork, every day. This is section. We meet 2 more days, we end the course, and then final exam is fast. So which is why I really want to make sure that people do it intensive. I mean, we can't procrastinate a little bit, but like I said, right, we have 2 days off, right? I give you leave 2 hours early, actually less than 2 hours early. But just want to make sure that you are committed to the classwork, and then I want you to be present every day. So this is what I want you guys to commit. So, and then when it comes to the class, I will definitely gonna help you out with those questions, except for Tuesday and Wednesday for both days because of the system, the Boeing system actually ruined our schedule, so it's make our class on Zoom, which is very inconvenient. But tomorrow we will definitely be on campus, so I want to show you all of the things again if required. And then tomorrow going to be the last topics is also going to focus on something really complicated problem, but at least we're going to know how to solve this trig equation. It's very doable. It's very doable. Okay, for this part it's hard. But we're gonna stick to that, okay? We're gonna stick to that. So let's do for another side function, and then another 2 side function, and then we're gonna jump to the cosine function. Let's say we're gonna do with sides of 2 sides of how many x do you want? So maybe 5x, so that's 3x and minus minus pi over something, minus pi over 4, or pi over 4, whatever. Okay. Okay. Are we good with this? Now we can see that. Okay, so now what we have to do, we need to identify one more thing, which is very important thing. I just actually leave out with something like this. So what is the amplitude, right? So we need to know what it is. How can you figure it out? It's 2. Okay. Why nobody helping me? Please help besides where is 2, correct? Am I going too fast with this? Okay. So how about the period? So it's not going to be the same. Why 5 pi? The periods is look at the coefficient. It 3 pi. No. So the periods will be 2 pi, correct? 2 pi's for a single x. But now you have 3x. What should we do? We're going to divide by 3. That's it, right? That's it. Divided by 3. It's 2 pi over 3. Simple as that. Okay. Are we good? It's just divided by 3, right? So whatever the coefficient, let me just put, I think that people still don't get it. So for whatever the coefficients that we have is always go down to the bottom. So if you forget it, what should we do? I'm gonna take notes. I'm gonna give you guys notes for it. Okay. Okay. Everybody sees that? So now the next thing that is actually a little bit hard. So we're gonna go for phase shift. I'm going very slow, just want to make sure that people get this right because this question gonna be in a final exam. I just looked up. Okay, it's okay. It happens. It happens for that. But now the phase shift is we call the horizontal shift. Okay, you're gonna shift to the right or shift to the left. Okay, the phase shift we call the I just want to make sure that people understand what it means by the phase shift is horizontal shift, right? Horizontal shift meaning that it's shifting the x index, right? It's shifting the x to the left or to the right. So shifting the x index. So I'm not going to put the x. Everybody know that shifting of x meaning shifting to the left or right. Are we good? Is that good, people? Does it understand? Does it make sense for you guys? The phase shift. It is like the horizontal shift meaning that we're shifting the index of x or shifting the x index either on the left side or the right side. So how do you know it's so this one, the pi over 4 have to go with the x, right? Have to go with the x, so we have to shift the x index. Are we good? So shifting the x index either on the left side or the right side. Are we good? So now, in order to figure out phase shift, we're going to do what? Anyone still remember? Anyone still remember what it is? We shift to the right. Very good. Very good. Because this is minus, right? So whenever you see the minus, then we have to shift that function to the right. And how much are we going to shift it? So pi over 4, but pi over 4 for x. So now we have 3x. So again, we do a trick again that we're going to divide by 3. So instead of pi over 4, that we're going to go by pi over 12. Does it make sense? Does it make sense? Let me just show you what it is. Yeah. me just put that down. Are we good? Does it make sense? So this is minus, right? If this is minus, we shift to the right, so it's positive. So we're gonna take pi over 4, and then we divide it by 3. So we're gonna take pi over 4. I'm doing very slowly, okay? So it's just the same thing for period. So we have to divide it by the index that come before the x. So pi over 4, right? So we're gonna shift to the right, pi over 4 usually, but since we have 3x, so we have to multiply by 3. Correct? We have to divide it by 3 actually. So when you divide it by 3 on the bottom, we have to multiply 4 and 3 together. Are we good? Does it make sense? Hello? Okay. Yeah. So so in other words, the phase shift gonna be C over B. So the C, the negative, so we change from negative to positive. So that'd be C, so this is pi over 4. We just divide it by B. We have to divide it by B in this case, so that'd be C over B, which is pi over 4 over 3, so that'd be pi over 12. Are we good? Hello? Okay, so please help me, give me some reaction because I want to make sure that people understand it before I move on. So I don't want people just like sit down, just tell me that if you understand it, yes, we good. I just want to make sure that people not left over. If you don't understand, please ask question. Okay, so now a very important thing that the phase shift gonna start. So remember, what is the psi function started from? The psi function start from 0, correct? Most likely the psi function start from 0 if there's no phase shift. The phase shift is 0. In this case, the phase shift is 0. So we start from 0. But now if the phase shift is pi over 12, so we know the fact that when you have minus 1, you have to move to the right, correct? So if this is pi over 12, so we have to move this to pi over 12. This is hard. This is hard. Are we good, people? So we have to start at this point. Okay, we have to start at this point. Okay. Are we good? So I'm gonna sketch it first. I don't care what the rest of them, I just sketch it first. And then I put this down on top is 2 and -2. So, okay. Yeah, yeah, that's correct. So the phase shift is shifting to the left, right? You see that? It's shifting from the left to the right. So meaning that we're gonna shift that instead of we starting from 0. So this is what people asked me the questions earlier. So we don't start from 0 if we have a phase shift. Okay, we always start at 0 if there's no phase shift. But usually on a final exam, they're gonna give you the phase shift. So we need to shift the curve. Okay. And then you need to understand the behavior of a sine and cosine. Yes, we have to start by sketching the phase shift first, and then we can determine no index later on. It's cheating. I know it's cheating, but it's actually the way. I'm not gonna confuse you, like, but you need to understand what the psi function looks like, right? No, it's starting from, yeah, it's from the amplitude is 2, so we have to be going up 2 and going down 2 no matter what, right? Right. So this is no, not necessary, but yeah, that is a good question. A lot of, yeah, if we start from 0, the end will be 2 pi over 3. Okay. Now it start from pi over 12. What do you think is going to end? because we don't start from 0. So if we start from 0, right? So let's say if we start from 0, it's gonna end as at 2 pi over 3, correct? So this is what it started. So let's say we start from 0. It's gonna end a little bit further, right? A little further than 2 pi over 3. It's a little bit more. So if this is start from 0, so we should definitely know that it's gonna end at 2 pi over 3, correct? But now it doesn't start from 0. What should we do? How can we determine the index here, people? I mean, I know how to sketch the graph because the side functions always go like this, and then another curve is go like that, right? It's the same period. But what I'm saying, how can we determine the mid period and the ending period for that, right? The ending period of a curve. Any idea? So the whole thing is 2 pi over 3, correct? The whole thing is 2 pi over 3, so we knew it, right? So the whole period is 2 pi over 3. Okay, but I want to know what is the end point on X. What should we do? Hello? What should we do? Yes, exactly.
So I'm gonna ask that the
That's correct. So we need to add them, right? But so because we move 1 over 12, we're gonna add 2/3. So that's might be a big problem. So we're gonna add those 2/3 with 1 over 12 pi, and then you're gonna get something with a pi. So that's one is really confusing. That was just really so no, you're gonna add pi over 3 first to get a half period, and then you're gonna add another pi. So the half period gonna be pi over 3 because the whole period is 2 pi over, so half period is pi over 3. This is a problem. I know how to sketch the curve because it should go like this, but the problem is the true matter is you need to figure it out the point, the ending point, like half period. So the half period is pi over 3. You're gonna add pi over 3 and pi over 12. That's part so confusing. Yeah, anyone can help? Anyone can help? So how can we add pi over 12 with 2 pi over 3? We just do the math, correct? Gonna take 1 over 12 plus 1 over 3. You're gonna get half period, right? This point's here. And then you're gonna take 1 over 12 plus 2 over 3. So you're gonna get the ending period. Are we good? Does it make sense to people? I mean, if we start from 0, that's simple. We just move like pi over 3 and 2 pi over 3. That's it. We end the story. But now we start at pi over 12, which is not at the point 0. So we have trouble. Correct? We have trouble. Right? So we definitely have to take 1 over 12 plus 1/3. You're gonna get the half period. 1 over 12 plus 2/3. You're gonna get the ending period. Are we good with this? Are we good? You have to add like a 1/2 of, I'm saying 1 over 12 the period for this. So how can we add 1 over 12 and 1/3? What should we do? So we're gonna look for the common denominators. 1 over 12 plus, so 1/3 is 4 over 12, right? 4 over 12. So this one is, so we look for the common denominator is 5 over 12. And this one is 1 over 12 plus 2/3 is 8 over 12, right? So that'll be 9 over 12. 9 over 12 is 3 over 4. Okay, 3 over 4. Why 1/3? Because the whole period is 2/3, right? So half period is 1/3. So I need to determine like the half points right there. This is the half point, right? This is the point where this one equal to 0. Yes, so that would be 5 over 12. So why I ignore pi? Because the same thing, but we need to rewrite them as 5 pi over 12 in this case. And this one is, so we're gonna add 1/12 plus 2/3. Remember, 2/3 right here. And then the period for this, we look at a fraction. The fraction is a pragmatic issue for the for this question. So 1/12 plus 2/3 is 3/4. Okay, are we good? Yeah, we cheated, but we cannot cheat those two. The hardest part is to determine those two. Are we good? Oh, this one's tough. If you see these questions on a final exam, would you be okay? Would you be likely get full credit for these questions or no? It's tough. It's Crystal said tough. 50%. What a shame. 50%. Yeah, you have to add. So we think. So let's say we start from pi/12. We think of it as 1/12. We just add the half period, which is 1/3. So the half of a 2 pi/3 is 1/3. And then gonna if you can't determine this point, I take away 1 point only. Okay, if you only have like pi/12 and 3/4, I give you almost full credit for it. Okay, is that fair? Is that fair, people? You don't have to add too many fractions, but we need to add pi/12 plus 2/3, 2 pi/3. So instead of we adding those, we just take the fractions, 1/12 plus 2/3. You get to the final answers. All right. I know it's tough. I know it's tough, but I decided to give you even tougher questions. Y equal to -3 sides of 2x minus pi over minus pi. Okay, so now determine the what is the aperture for this? Is 3, correct? 3. Yes, 3. 3 is 33. It's positive. Always be positive. And it's -3. I will show you why. We just flip the curve. So the negative side here, we just flip the curve. The negative side means flip over x-axis. Okay, flip it over. Okay, so what is the period for this? The period is so 2 pi/2, correct? 2 pi/2 in this case. So we take 2 pi, right? It's always start with 2 pi, and then we have to divide it by the number that you see for x. Or we have to take 2 pi, and then so we see the 2x, so we just divide it by 2. Are we good? So the answers for that is pi. Are we good? Are we good with this? Okay, now we're gonna go for phase shift. Phase shift. Okay, phase shift, that's the problem. Okay. So anyone remember what is the phase shift formula? So you're gonna take, so this is minus, right? It's become plus. If this is plus, so let's say can we change the question to plus pi? So we're gonna start from the left, okay? Are we good? So can we change the question to -3 sides of 2x plus pi? Just wonder. No, we changed that, so we have subtract. We shift to the left, so we're gonna subtract them. So instead of the phase shift started from, it should be from positive. This one's minus. If this one's minus, so we have to be pi, but this one plus, it'll be -pi. Are we good? And then for whatever the value that we have, for the coefficient, we just divide it by 2. Are we good? Divided by 2. Does it make sense? So we're simply just taking like a C over B. So it's B, so we take the C, so we have negative, that becomes C, we have a positive, that become negative C over B, over the coefficient that we have for B, okay? Are we good? Are we good with this? So we have trouble, then you have to tell me what it is, right? And then the negative side we flip over the x-axis. So now we're gonna sketch the curve. So we start from -3 and 3, are we good? And then where should we get started? So this is -π/2. So this is where we get started. Are we good? Are we good with this, people? Right? And then it should go like this, correct? Oh my goodness, so. Oh my goodness, I can't draw it properly. Okay, are we good? But now do you see the negative sign right there? The negative sign in front of the in front of the function? Everybody sees that? So what should we do? So we're gonna flip over. We do the opposite. Oh my goodness, finally I draw a good picture. Okay, and then okay, stop right there. So now the painful part is you need to determine the point, those 2 points, the midpoints, and the ending period, for this. So the another period going to be like this, right? The same thing. So we have to start here. It keep going forever. You can't keep on going. You can start right there if you want to. Doesn't matter which one. So it's keep going forever. So how can you determine this point, people? And this point. Yes. We're gonna add. That's correct. It's basically add them, right? I think I make the curve like actually too long. I think I draw the wrong graph. So it's pi plus. Oh yeah, I actually got it right. But the midpoint going to be pi/2. So I think I draw a really terrible graph. It should be right here. I'm so sorry, but I have to redraw them because it's gonna cut at 0. I just did a map wrong. I'm sorry about that. So should redraw them. Okay. I really have such a hard time, especially drawing skill. Told you guys. All right, so it's almost there. Okay, so now it's getting better. It's because I know the fact that it's gonna cut the midpoint at 0. So so the half period is pi/2, right? The half period is pi/2, so the whole period is pi, and then we're gonna take negative pi/2, -1/2 plus 1, right? So negative pi/2, which is -1/2 plus 1 is 1/2, 1/2 pi. So this one just simply pi/2, correct? Are we good? So what is the midpoint between negative pi over 2 and pi 0 and pi over 2 is 0? Correct, is 0. Yeah, exactly. Or we can simply take negative pi over 2 plus, so 1/2 of the period be one, which is pi 1 over 2, pi over 2 is 0. So this is half period, right, the midpoint. This is the end point. Okay, are we good? Okay, we just take the phase shift, we just add the period, you're gonna get the endpoint, right? The endpoints. And the endpoint is just like take the phase shift. Phase shift. And then add the period. Okay. All right. I feel like that is good to know how to sketch the psi function. Now we're gonna go for cosine function. Are we good? And then we're gonna have a quiz. We're gonna class break. We're gonna come back tomorrow. I will see you there. We're gonna work through it. And then if questions, you can ask me question, and then we're gonna go over another 2 topics, and that's it. Okay, that's it. We are very exhausted for the entire thing. Okay, so are we good with this? So now we're gonna go for cosine. Are we good? So we start with cosine. The cosine, let's say we started with 2 cosines of let's say start with 3. I feel like it's better. 2x plus pi over 3. Are we good? Okay, so what is the phase shift? What is the amplitude for this? It's 3, correct? So very good. People, please help. And what is the period? I think it's 2x is the same thing as period is pi. And so it's 2 pi over 2. So we take 2 pi and then we divide it by 2. It's essentially equal to pi. And then we also have, what is the phase shift in this case? How can we find a phase shift, people? No, negative. Yeah, shift to the left, so it's negative. Very close, Annie. We're gonna take pi over 3. We divide it by whatever the coefficient we have. The period is different. You're gonna take 2 pi divided by whatever that we have, but in this equation, you're gonna change the sign. That would be negative pi over 6. It's very close. It's actually almost correct. But we need to make sure that it have to shift to the left side, right? Maybe you actually got it wrong, but on the graph, you shift to the left, I give you full credit for it, okay? So makes let's say we mess up the size, or it doesn't matter. So this one's negative because this is positive. So now we're gonna sketch the curve again, that we're gonna start with the curve. I forgot to put down the range for this. So the range is negative 3 to 3 is correct, negative 3 to 3, and then the domain is OX. I don't like to write infinity and past infinity, so just put that OX in this case. All right, so we're gonna start from negative pi with 6, so assuming this is negative pi with 6 over there. Actually, it doesn't matter which one, so just want to make sure that this is negative pi with 6. Okay, so now what the cosine function looks like. Cosine started from 1, right? Started from this, and then it go like that, right? So we have to put your hands up again. That's gonna twist it. So it started from the highest point. So the cosine started from the highest point from 1. So we We knew it from the previous curve, so it started from 3 to -3s. Okay, so we look at this graph. Right, so start y equal to 1 for cosine, and then this one is gonna be the same, gonna start from 3, right? Are we good? Are we good with this? Yeah, actually 2x. So let me just check pi over 2. The phase shift is, so we're gonna add half period. Half is pi over 1, half is 1/6 is positive. Okay, as long as positive, I'm happy. Okay, anyway, so yeah. Okay, are we good? So this is the end period. So now the problem is we need to determine the lowest point from the half period and then the highest point again. So what should we do? How can we do that? We're gonna take 1/6, -1/6, right? Plus pi, plus 1, which is pi, right? The whole here is 1, so that'll be 5/6 pi. So the ending point should be 5 pi over 6. Are we good? Oh my goodness, I have such a hard time to sketch those. 5 pi over 6. Are we good with this, people? Hello? Are we good? Okay, so now half of that. I have a suggestion. So we can just add them up divided by 2. You're gonna get half the midpoint. Add 5/6 and -1/6. We add them up divided by 2. Instead of we take -5/6 plus 1/2. So I feel like it's much better. So let's say we just add them up one half and -1/2, and then we add them up divided by 2. You got 0. This case, you're gonna get 5/6 minus 1/6 will be 4/6. 4/6, we simplify them, so that would be 2/3, right? So this one is 2/3. 2/3. Are we good? So you need one more example? I mean, the sine, cosine is pretty much the same, but the cosine we have to store, and then we just need to memorize the shape of that. I give you full credit for it. I mean, it should be like go half of the period to reach 0, a quarter of a period, and then start going down, and then it's gonna read a quarter of that. It's going up, but it doesn't matter. It'll just be approximately, right? Approximately, this is what a curve looks like. Okay, are we good? So if you see these questions on the final exam, which be okay. Right, let's just go like this. Maybe you want to add another 1, so let's say add 1, you're gonna have to shift the curve up 1 unit, so it will be 4 and -2 right here. When you add 1s right there. So okay, so are we good? You need one more example? Yes, okay, one more. So what kind of example that I should give? Let's say we do this one, call it day, right? Okay. Save it. All right. Okay, so this is what a function looks like. Now, phase shift. I'm sorry, the aperture. 3. Very good. Period. It's 2 pi, correct? It's 2 pi, so there's no change for it. I love this question. You don't have to divide it. Divided by 1. Are we good? Divided by 1. Phase shift. This one actually easier. Phase shift is what? Pi over 3 over 1, correct? This is pi over 3. Negative sign over here. You'll flip over, right? Flip over the x-axis. Okay. Plus 2. This is a vertical shift. 2. Up 2. This is right. Okay. Are we good with this, people? Are we good? Yeah. What is the range? What is the range of the function? What is the range? What is the range for the function? No. With plus 2. So 3 plus 2, negative 3 plus 2, correct? So it's plus 2. Vertical shape, we have to shift up a little bit. So the shift up gonna give me the range go to 5 and negative 1. Are we good? Is that good, people? So 5, negative 1. And then there's a horizontal lines right there. It's gonna split up the curve. There's 2. Okay. A shift up 2. We just have to bring the curve by 2. We started pi over 3, correct? We started pi over 3, so this is pi over 3. Are we good? And now how the curve looks like. So the endpoint's right here. So it's gonna go like this, correct? I know it doesn't look so good, but don't make fun of my graph. I know it's gonna be very horrible. I'm trying to do that better. Oh my goodness, so it's still very horrible. I cannot get rid of the fact that my drawing is still terrible for this, so. All right, is that good, people? Is that good? Is it the right curve? We have a negative side, I flip over the x-axis, right? So I have to do the other way around. All right, that's it. It's look like the bell shape. The bell shape right here. It's look like that. The bell shape. Anyway. So are we good? So 2 plus 1/3 is 7. pi over 3, so this one is 7 pi over 3. This is the endpoint. Usually you don't see this question. Right, because if you start phi, you're gonna go like this, right? But we have a negative sign in front, meaning that you have to flip over. You have to do the opposite. You flip it over. Okay. So we start at -1 instead of -5. Are we good? Do we understand how we're gonna get the range correctly? We just simply add a number of values here. Are we good? It should be -1 and phi actually, so instead of phi, -1. I'm sorry, I make a little buff here. Yeah. But do we understand why we have to start at -1 instead of +5? Because we flip over the x-axis, right? And a half of this is 4 pi. No, we add them up. It's 4 pi over 3. Okay, so I believe that's pretty much it. I don't think it's gonna, you will never get some questions like crazier like this on the final exam. This is basically the hardest question. Okay, this is pretty much the thing. Are we good with this, people? You know the difference between sine and cosine? You know how the phase shift work? You know how we're gonna get the midpoint? Something like this. Okay, are we good? Are we good with this, people? All right, so we're gonna have a quiz and classwork. Get ready for it. Well, I'm gonna post the quiz and classwork here. It's open book, okay? It's open book for quiz and classwork. Is that fair? Okay, so what are the quiz questions? So the questions of the quiz gonna be on the inverse. You're gonna find the inverse of the tricks, okay? And also you're going to find this one. You're gonna go to lecture notes, and then you're gonna go back there, and then you have to use. So let's say I give you the secant. You're gonna figure it out the tangents or sine, cosine. No, it's the. I would say you're gonna. I'll let you. I would let you finish it by 2 p.m. Okay, by 2 p.m. Or maybe I will finish it by 5 p.m. So for the quiz, is that fair? It's open book. You cannot be get wrong. By 5 p.m. for the quiz question. Let me just post it. The quiz. Is that fair, people? Quiz 5. So now you like the online class because it's open book. Okay, so yeah, the due date is 10 point. So you can have many submissions. So we do the same thing that we do. Make sure they're gonna take photos, right? After you finish it, it's 1 page. You don't have to convert to the PDF file, just submit it. Make it due by today as 5 p.m. Is that fair? Okay, I'm not gonna go over it. But we can. Yeah, if I go over the quizzes, I don't know why I'm testing you. So now we have another classwork. So let me just do it. So classwork and make it due tonight. Okay, classwork 8. It's like this. So period of function, amplitude, phase shift, complete 2 cycle. You don't have to estimate it, you can ignore it. So when you do the classroom, you just ignore those numbers. You don't have to be exactly pi is like 3.14. I know but it's hard. Just get rid of those numbers, right? And then just replace your own numbers. Okay. The same thing for that cosine sine function. All right. This is what we have for classwork, and is due also tonight, so please do it. Classwork 8. Are we good? It's 5 points. Okay. We have another classwork tomorrow and another optional quiz tomorrow. And I feel like that's pretty much it for the entire course. Okay. All right. So any other question? How does it feel? Like, how do you feel like about the trig functions and all kind of things? It's not too bad if you have a unit circle. If you have a unit circle, everything is not too bad. But if you don't have it, it's gonna be a big deal. So the quiz question again is gonna be on this stuff, and then you have to find the inverse. We just went over it. I want to upload it out of this soon. And I think I can do it now, but I have the old files. I need to clear up those pictures real quick. And let me just go to the lectures here.